One of the biggest problems we face is erosion on our coastlines from point source pollution, multi-source pollution, and agricultural runoff from increased populations. And so what we're doing is designing structures that will mitigate that erosion. We have started focusing on modular designs that incorporate different mesh densities. We can deploy reefs in specific areas where the topography needs it the most, where you experience the most sedimentation. Maybe you face it in and you intentionally have that part of the reef subside, because eventually you get a sediment buildup on one side. And when that sediment buildup happens on one side of the reef, the other side of the reef creates this really complex valley. You need these kinds of features to develop, and it's hard to make them easily deployable. But when you design it so that nature creates it itself, it works out. When working with a hatchery, for example, they release juvenile species when they're about 1 to 2 inches long, which is still very tiny, and without the natural structure and the decrease in seagrasses, majority of them will die because of predation, pollution, lack of structure and habitat. And so what we're trying to do is make it a more successful process. We're building up the ecosystem by attracting a diverse array of species rather than just one. We're building observation tools on top of providing habitat. So we know that there is a lack of habitat, but we don't necessarily know the extent of the problem. We know that we have multiple different pollutants that have decreased the population sizes of relevant fish species, especially after the BP oil spill. We are doing some biodiversity and abundance sampling. We're measuring the biological and chemical components of the current habitat, the Gulf, the bays, the bayous, tracking their status over time and trying to project what we can do to benefit each of those different ecosystems. And so in order to do that, we are developing habitats that include monitoring equipment on site in real time. So you can use light to actually take these water quality readings using nephelometry and backscatter and spectroscopy, and then communicate it using Li-Fi, using directed beam communications, using either AUVs or drones that would fly overhead and transmitting the data to an onshore database. We're making it into consumable information for the general public, as well as scientifically backed by EPA and FWC protocols. In a way, it gives the environment a voice.